going to show that this surface integral of x square I vector plus y square j vector plus z square k vector, its dot product with n vector ds is equal to 0, where S denotes the surface of the ellipsoid x square by a square plus y square by b square plus z square by c square equal to 1. So we need to apply the Gauss's divergence theorem over here. So the given integral is this and the surface is the ellipsoid, right? Let's consider the region V enclosed by the surface S, and to solve this surface integral, we are going to apply the Gauss's divergence theorem. Then, by Gauss's divergence theorem, this surface integral is equal to the volume integral of the divergence of this vector. And for the divergence, we write del dot of this vector. Please note over here, the divergence of f vector, that is del dot f vector, is equal to, what is del? It is curly by curly x I vector plus curly by j vector plus curly by z k vector. And the components of f are written as f1 I vector plus f2 j vector plus f3 k vector. On taking the dot product, we get curly f1 by curly x, that is derivating the first component with respect to x, plus derivating the second component with respect to y, plus derivating the third component with respect to z. This is what we do over here now. So this is equal to volume integral of derivating the first component with respect to x, plus derivating the second component with respect to y, plus derivating the third component with respect to z, dv. So curly by curly x of x square is 2x, and then plus 2y plus 2z. So this is equal to the volume integral of 2x plus 2y plus 2z dv. Taking 2 common, and we get the volume integral of x plus y plus z dv. That is equal to twice of separating the terms, that is volume integral of x plus volume integral of y plus volume integral of z. Now as we are getting the symmetry, let's solve the first integral. So the volume integral of x dv, that is equal to the triple integral over the surface S, and the surface S is your ellipsoid, x dx dy dz. Now as the surface given to us is an ellipsoid, that is x square over a square plus y square over b square plus z square over c square equal to 1. We can get the limits of x from here as 1 minus y square over b square minus z square over c square under the root with plus minus sign, right? So the lower limit is negative of square root of 1 minus y square over b square minus z square over c square, and the upper limit is positive square root of 1 minus y square over b square minus z square over c square, right? Now this innermost integral is over. We are interested in yz. For yz plane, we take x to be equal to 0 in this surface and getting the limits of y in terms of z. So what we get? So we are getting y to be equal to plus minus 1 minus z square over c square under the root. So the limits of y becomes, the lower limit is negative of square root of 1 minus z square over c square, and the upper limit is square root of 1 minus z square over c square. Is it fine? Okay. Alright. Now the remaining integral, that is with respect to z, we are interested in only z coordinates. So for z, we take x to be equal to 0 and y to be equal to 0 in the surface S and getting the limits of z. So we get the limits of z to be as, taking x and y equal to 0, we get from the surface that it is plus minus c. right? So the lower limit is negative c and the upper limit is positive c. Please notice that here x is the odd function. What is the odd function? If f of minus x is equal to minus of f of x for all x in the domain of f, then the function is odd. And if f of minus x is equal to f of x for all x in the domain of f, then the function is even. So here x is the odd function. And for an odd function, if the integral is having the same limits with opposite sign, then that integral of an odd function is 0, right? So the value of the innermost integral is 0. So this complete integral is 0. So by symmetry, similarly, this integral is also 0 and this integral is also 0. So as x is an odd function, the value of innermost integral is 0. This implies the complete volume integral of x is 0. Similarly, the volume integral of y is also 0 and the volume integral of z is also 0. Let's mark this equation as 1. So from equation 1, so this is equal to first integral is 0 plus second one is also 0 plus third is also 0. So we are getting the surface integral to be 0. Hence we have shown that the given surface integral is 0. Alright, thank you. Stay blessed.